In a moment, we will explain you all the important things, which have something to do with the theme, electromagnetic waves. First of all, we are going to explain what the electromagnetic spectrum is. Scientists classified this electromagnetic radiation in the electromagnetic spectrum according to the wavelength and photon energy. There is a part of electromagnetic radiation perceptible for our eyes. We call this section the visible light, but this is only a very small part of the entire electromagnetic spectrum. This frequency range is divided into separate levels, and the electromagnetic waves within each frequency band are called by different names. Beginning at the low frequency end of the spectrum, these are radio waves, microwaves, terahertz waves, infrared, visible light, ultraviolet, X-rays, and gamma rays at the high frequency end. The electromagnetic waves in each of these bands have different characteristics, such as how they are produced, how they interact with matter, and their practical applications. There are a few important terms relating to the electromagnetic waves. We are going to explain them one by one. 1. Reflection. I think you all know the meaning of it when it's related to light. For example, when sunlight falls in on a mirror. If an object emits a wave, these could be reflected back by another object. The angle of incidence is always the same as the reflection angle from a straight wave. Straight waves cannot fall in vertical on a flat screen, therefore the Gauss rays are not perpendicular to the surface. 2. Interference. It is a concept that represents the impact which two waves have on each other when they go through the same medium. For example, if two parallel waves come together, it will give us a stronger one. This is constructive interference, and the resultant amplitude would be equal to the sum of the separate waves. But on the other hand, we see that two waves cancel each other out because one wave goes up while the other goes down. We call it destructive interference. Refraction. The transition from waves of one medium with certain wave speed to another medium with a different wave speed causes refraction. The angle of incidence is after the refraction no longer equal to the refractive angle. For example, a light beam which goes through the water. 4. Diffraction. The most easy way to describe it, waves bending around an object. It shows up when waves penetrate the shadow area of an obstacle or behind a screen with small opening. The wavelength remains the same before and after the gap. The smaller the gap, the greater the diffraction. The longer the wavelength, the greater the diffraction. We are going to discuss different kinds of applications of electromagnetic radiation. A lot of things in our daily life work because of radiation, and here are a few examples. Radio, TV, wireless phones, GSM, smartphone, Wi-Fi, hard disk computers, microwave, the use of microwaves for heating food and industrial applications, and so on. But of course not all radiation is the same, and we will sum up the different types of electromagnetic radiation. First of all, there is Röntgen radiation, also known as X-rays. They are high-frequency and ionizing electromagnetic rays. X-rays are used as a security device at the airport. Travelers' luggage is checked in this way. X-rays are of course also used in hospitals. Bone fractures can be demonstrated with this type of radiation. Another type of radiation is gamma radiation. This is used for sterilization. This means that gamma rays can kill living cells, so they are used to kill microbes and bacteria on fruit and vegetables. This technique is also used in hospitals to sterilize medical utensils.